Welcome back, guys. This is question 4.1 of chapter 4, which is related to the mathematical expectation. And the statement of our first question is the probability distribution of X, the number of imperfections per 10 meters of a synthetic fabric in continuous rolls of uniform widths, is given in exercise 3.13 on page 92 as the values of X are given and the probability density function of it is also given here. Okay, so that is the density function, or we can also call it the PDF. Okay, so this is the PDF of X. So on the basis of this data, we have to find the average number of imperfections per 10 meters of this fabric. Okay, so we have to solve it, and here we have to find the average number of imperfections, which is basically the mathematical expectation. If you want to find out the expected value of a random variable X, which is also represented as mu, we can always find it out by multiplying the value of a random variable, which is X, with the density function of it. Okay, so this is f of X. And if we have more than one random variable, let us have x1, so we have to multiply it with the fx1, which is the probability density function of x1. Similarly, if we have also x2, so multiply it with fx2. Okay, and so on up till and until we have xn f of xn. Okay, similarly, we can also represent it with what? We can represent it with x subscript I and f x subscript I, where I starts from 1 and ends at n. Okay, so that is the mathematical expectation or the average value. Now here we have the values of x, we have the value of f of x. So what do we have to do here in order to find the expected value of x? Let us multiply the values of x with the corresponding density functions. So here what we will have, let us multiply the 0 with the corresponding value of it, which is 0.41. So 0.41 plus 1 multiplied by 0.37. So 1 multiplied by 0.37 plus 2 multiplied by 0.16. Okay. 3 multiplied by 0.05 plus 3 multiplied by 0.05, and here 4 multiplied by 0.01. 4 multiplied by 0.01. Okay, so multiplying them together, what will you get here? It will be 0. Okay, and all other values will become 1 multiplied by 0.37, 0.37 plus 2 multiplied by 0.16, 0.32, 3 multiplied by 0.05, this is 0.15, and plus 0.05, sorry, this is the 0.01. So 0.01 multiplied by 4, so I will have 0.04. Okay, so now adding them all together, what will I get here? With the answer of it will be 0.88, and that is what, that is the average value which we wanted to find out. Okay, most of the people might have the doubts with respect to the expected value, that how can we find out the expected value like this one, because they have the doubts in their mind that if we have four numbers, let us have those numbers as 1, 5, 3 and 2, and if they want to find out their average, what do they have to do? They just add them together. Okay, and divide them over the number of items we have, and this is basically the case where all the items are equiprobable, because you can see here that this is the same scenario which we have represented here, because here it can also be represented as 1 over 1 by 4 plus 1 over 4 multiplied by 5 plus 1 over 4 multiplied by 3 plus 1 over 4 multiplied by 2. Okay, so here you can very clearly see that this 1 over 4 is what? that is the probability of each of the item here, because each one of them is equiprobable. So therefore this is 1 by 4. So this 1 by 4, 1 by 4, 1 by 4, 1 by 4, this is what, if you add them together you will get 1. So that is the probability density function, and each number here has been multiplied with the corresponding probability density function. So this formula also holds in our daily life as well, because they are the mathematical expectations are usually called the average of the numbers. Okay, so the same scenario has been used, but here in terms of the probabilities, if you will see them, you will also see the reflection of each method here in each other. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 4.2, and the statement of it is the probability distribution of the discrete random variable x is given as f of x, which is 3 choice x, 1 by 4 raised to the power x, and 3 by 4 raised to power 3 minus x for all the value of x which ranges from 0 to 3. We have to find the mean of x. Okay, so previously we have seen that the mean of any random variable expected value of x is always represented as from I equal to 1 up to n, and the value of the random variable multiplied by with its probability density function here. Okay, so here we can see that the values of I are basically ranges from 1 up to 4, because x1 is 0, x2 is 1, x3 is 2, and x4 is 3. Okay, so the values of x1, x2, x3 and x4 are given, which are here, we can very clearly see, but we don't know the value of f of x. So for x1 equal to 0, let me find the value of f of 0. So putting this value here in this formula, I will have 3 choice 0, okay, 1 by 4 0, because this is x, and 3 by 4 3 minus x. So 3 minus 0 is 3. Okay, so solving it, 3 choice 0 is what, this is 1 multiplied by 1 by 4 raised to power 0 is 1 multiplied by 3 raised to power 3 divided by 4, this will be 27 divided by 64. So ultimately we will get 27 divided by 64. This is for f of 0. Now for x of 2 equal to 1, here the value of x2 is 1. So we will have f of 1 equal to what? This would be 3 choice 1, 1 by 4 raised to power x, which is 1, and 3 by 4 raised to power what? This would be 3 minus x, 3 minus 1, that is 2. Okay, so let me solve it. 3 choice 1 is how much? That is 3 multiplied by 1 by 4 is 1 by 4, and here 339 divided by 16. Okay, so again 27 divided by 64 as well. Okay, similarly x3 equal to 2. Okay, we can see that x3 is equal to 2. Yes, so let me put the value of f of 2 here. So f of 2 would be what? This would be 3 choice 2, which is x. Okay, 1 by 4 as power x, so x is now 2. Okay, and 3 by 4 raised to power 3 minus x, so 3 minus 2 is 1 here as well. Okay, so 3 choice 2 is what? This would be 3 factorial divided by 3 minus 2 is 1 factorial, and this is again 3. Okay, 3, so this would be 1 over 16 and multiplied by 3 over what? 3 over 4. Okay, so I will have here 9 over 64. This is for f of 2. Now let me move down somehow to solve it for what? X of 4 equal to 3. This is f of what? This is f of 3, and here we will have the value of x is 3. So now 3 choice 3. Okay, 1 over 4 raised to power 3, because this is x, and also 3 over 4 3 minus 3 is 0. Okay, so 3 choice 3 is how much? This is 1. Okay, 3 factorial divided by 3 minus 3, this is 0 divided by 3 factorial, so I will get 1. So here I will have 1 over what? 1 over 64, and this is 1, so I will get over 1 over 64. Okay, so these are all the values, and we have got different values. Let me uh, plot them here as well. So here we have all the values of what? We have all the values of x and f of x. Okay, so the value of x are 0, 1, 2 and 3. Okay, so here, here and here. Okay, so this 0 is basically what? This is, let me see, that x f of 0 is 27 by 64. Okay, f of 1 is also 27 by 64. Okay, this f of 2, which is calculated, is 9 by 64. Okay, and this f of 3, this is 1 over 64. If you add them together, if you all add them all together, you will see that 27 by 64, 27 by 64, 9 by 64 and 1 by 64, you will get at the end what? 1. So this is what? This is the probability density function. Okay, you can also plot it as a PDF plot. Now, as you have found it out, you can find here the expected value, which is E of x, and for E of x you have to multiply the values which are here with the corresponding values of their probabilities, as we have previously seen. So let me multiply them together, and it would be 0 multiplied by what? 27 by 64 plus 1 multiplied by 27 by 64. Okay, 2 multiplied by 9 by 64. Okay, and 3 multiplied by 1 over 64. Okay, let me add them together. It will be 0 plus 27 by 64. Okay, plus this is 2 multiplied by 9, so 18 over 64, and here it will be 3 over 64. Okay, so adding them together and taking the LCM, let me take the LCM of it, and here I will get the LCM, and it would be 64. So 0 plus 27 plus 3 plus 18. Okay, so it will become 48 by 64, or these two are the multiples of 16. So I will also get 3 over 4. Okay, so the expected value of the random variable which we had here in the form of the formula, we have found out its expected value. Okay, so that's it for today, in which we have found out the mean of a random variable which we were given. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. Let us solve question 4.3 today. So the statement of it is, find the mean of the random variable t representing the total number of 3 coins in exercise 3.25 on page 93. Okay, so previously we have already solved exercise 3.25, so let us move to that page as well. So this was basically question 3.25, and I will put the link to this question in the description box. Similarly, it is also attached as a video card. Okay, so here we have a statement that from a box containing 4 dimes on 2 nickels, 3 coins are selected at random without replacement. Find the probability distribution for the total T of the 3 coins. Okay, so we had solved it, and I told you guys that the probability distribution for this was graphically shown as well, like this one. So similarly, the tabular form of it was also shown here, and it was here. Okay, it was the tabular form. from it we can very easily find out the expected value of x, which is e of x. And how can we find it out? By multiplying the value of the random variable with its probability. Okay, each value of the random variable will be multiplied with the corresponding probabilities and then adding them together. Okay, so let me use the same methodology here. So the first one is t equal to 20 and multiplying it with this probability, which is 1 by 5. So 20 multiplied by 1 by 5 plus 25 multiplied by its probability, which is 3 by 5. Okay, and the third one is 30 multiplied by 1 by 5. Okay, so 5 4 20 5 5 25 and 5 6 is here. Okay, so from it we can very easily see that it will be 4 multiplied by 1 and this is 15 and plus 6 multiplied by 1 is 6. So ultimately we will get what? It will be 25. Okay, so the total number here of t, or the expected value of t, which is we can also call t, because here x basically represents t, so that is 25. Okay, so that is what, that is the solution of question 4.3, in which we have found out the expected value of the distribution we had previously. So let me put the answer of it in the main question. So in solving it we have found out the answer, and that is basically the expected value of t is 25. Okay, so that is what 25, and the answer of it is here with the units which were given in the question. So that's it for today, and that is related to the mathematical expectations. If you have any question, you can ask in the comment box. See you soon. Hello guys, this is question 4.4 of chapter 4, and the statement of it is: a coin is biased such that a head is 3 times as likely to occur as a tail. Find the expected value of tails when this coin is tossed twice. Okay, so let me first of it write the given data. So in given data we know that the probability of heads is 3 times the probability of tails, so that's why 3 plus 1 would be 4. So therefore the probability of heads is 3 times in 4, while the probability of tails is what? That is 1 times of 1 by 4. Okay, so that is the total probabilities what we have been given here, and here we can very easily see that in adding them together, probability of heads, probability of tails, what would I get? It would be 3 by 4 plus 1 by 4, and here it would be 1, and that is the essence of any probabilistic experiment, that the probability distribution when added together we will get 1 out of it. So what do we have to find out here? We have to find the expected number of tails when this coin is tossed twice. Okay, so the sample space of it, that is also in the given section. So the sample space of it is what? Let me write the sample space of it when the coin is tossed twice. So it can either have heads, okay, or heads tail, okay, or tail heads, okay, or tail tail. So that is what, that is the sample space what we have here. And what do we want to find out? We want to find out the expected number of tails, and in finding the expected number of tails, the formula we have is, if we have the number of tails are represented with t and the random variable representing the number of tails are basically x, so the expected value of x would be what? That would be for x f of x. Okay, where this I will be from 1 to any number of items here, and this would be the subscript here. Okay, so that is the formula for the expected value, but we don't know this f of x. Okay, here we want to find out this f of x, and in finding it out here, let me represent the number of tails here with x. So in solving it, that is the solution, and here the probability that we have the number of tails is equal to 0. that is what, let me find out the events where the number of tails is 0, and that is the only event which is here. And the probability of heads we want to find out. Okay, so as the two events here are independent of each other, so therefore it would be the probability of heads multiplied by the probability of heads as well. Let me multiply their probabilities, which are 3 by 4. So 3 by 4 multiplied by 3 by 4, and it would be 9 over 16. Okay, so that is what that is for t equal to 0, or the x equal to 0, which is the number of tails in any event of tossing a coin twice. So here we have, similarly after it we have to find out the probability that the number of tails is 1. So what are those events? We can see that this is and this one, these are the two events where the number of tails is 1. So therefore we have to find out the probability of heads tail, okay, and tail heads. Okay, we have to find out their probabilities that either this or this event can occur. So we can see that here or is coming in between them, so therefore oring means adding them together. So therefore we will have here heads tail or plus probability of tail heads. Okay, so this is what we have. As again we can see that these are basically the two separate tosses, so the two events are independent of each other, so these events will be, their probabilities will be multiplied with each other. So probability of head multiplied by probability of tails plus the probability of tail multiplied by the probability of heads. Okay, let me put their values, and probability of heads is 3 by 4, probability of tail is 1 by 4, and probability of tail, which is 1 by 4 multiplied by probability of head, which is 3 by 4. Okay, so multiplying them together and adding them together as well, because this is the OR event, because either of these events can occur as I have previously described. So I will get here 6 by 16, which is for probability that tails equal to 1. Okay, so here also the last part is in which we want to find out that the probability that we have got two tails, and that is the only event here in which we have got two tails. So it would be probability of tail. Okay, and as again the two events are independent of each other, so probability of tail multiplied by the probability of tail, multiplying their probabilities, which are 1 by 4 multiplied by 1 by 4, so it would be 1 over 16. Okay, so that is for the tail equal to 2. Now let me put them in tabular form. So in putting them in tabular form, here this is a table which is, let us have this x, the number of tails in two coin tosses, and the distribution of it, let me have here p of x here. Okay, so the values of x can be 0, 1 or 2. Okay, so these are what we had, because previously we have seen that, let me move upward here as well, we have seen that the number of tails in two coin tosses, we can either have the value of it 0 or 1 or 2. Okay, we have also found out their probabilities as well. So for 0 it was 9 by 16, for 1 it was 6 by 16, and for 2 it was 1 by 16. Okay, we can also see it very clearly that when these three will be added together, I will get 1, and that is the prime condition for the probability distribution. Okay, so that is what we had here. Now for finding the expected value of the random variable, which is the number of tails in two coin tosses, we have to use this formula. Okay, in using this formula, let me use the expected value of x, and this would be what, now I have to multiply the value of the random variable with its corresponding probability. So therefore 0 will be multiplied with 9 over 16, okay, and adding them with the other random variable multiplied with the corresponding probability, I will have here 1 over 6 by 16, okay, and after it we have 2, and multiplying it with its corresponding probability, I will have 1 over 16, okay. So after calculating them all and finding them, I will get 8 over 16, which is 1 over 2, okay. So the answer of it is what? That is basically 1 over 2, and that is the solution of our question 4.4. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So in today's video, we will try to solve the relevant questions of chapter 4. So these would be question 4.6, 4.7 and 4.8. Okay, so let us start our video by solving question 4.6. Okay, and so the statement of it is, an attendant at a car wash is paid according to the number of cars that pass through. Suppose that the probabilities are 1 by 12, 1 by 12, 1 by 4, 1 by 4, 1 by 6 and 1 by 6 respectively, that the attendant receives $7, $9, $11, 13, 15 and $17 between 4 p.m. and 5 p.m. Okay, so the amounts have been written here, and the probabilities of getting this much amount has also been given, okay, respectively. So we have to find the attendant's expected earning for this particular period. So in finding the expected earning, we have a formula, and previously we have seen that this is called the expected value. So expected value of any random variable x can be found out by writing the value of a random variable, multiplying it with the probability it has. Okay, so this is what for a single random variable. If we have the multiple random variables, then we have to find out the expected value of it by writing the first random variable, multiplying it with the probability it has, and adding with it the second random variable, multiplying it with its probability, okay, and then x3 px3, okay, until and unless we will reach the last random variable, that would be x of n. Let me write it. Unless and until we will reach x and p x of n. Okay, so this is what this is the expected value of a random variable. Okay, so on the basis of this, let me solve question 4.6. okay, and the solution of it is here. Okay, it has a solution, and we have different values of the probabilities, which are 1 by 12. Okay, so let us find the expected value of a random variable x, and we have probabilities which are 1 by 12 of what? That is of 7. Okay, $7. Similarly, 1 by 12 of 9. These are the what? These are basically the, let me write them here. This is 1 by 12 is what? This is the probability, and here x1 is this 7. This is the value of a random variable. Okay, so I hope you have understood that why am I writing these values here. So 1 by 12 multiplied with the value it has, that is 9. Okay, also the 1 by 4 multiplied by the value it has, and that is 11. Okay, and again 1 by 4 multiplied by the value, that is 13. Okay, the next one is 1 by 6. So 1 by 6 with the value it has, and that is 15. And the last one is again 1 by 6 with the value it has, and that is 17. Okay, so this is what, this is the formula which we had here, because here this is, this is px1, this is px2, this is px3, px4, px5, px6, while this is x1, x2, x3, x4, x5 and x6. Okay, so let me take the LCM of these quantities, and the LCM of it would be 12. Okay, and it would be here 12. 1 by 12 multiplied by 12 would be 7 plus 9. Okay, here it would be 1 by 4 multiplied by 12 will be 3, 3 multiplied by 11 would be 33, plus 1 by 4 multiplied by 12 is 3 multiplied by 13 would be 39, okay, plus 1 by 6 multiplied by 12 is 2 multiplied by 15 is 30, and the last one is 1 by 6 multiplied by 12 is 2, 2 multiplied by 17 is 34. Okay, so these are the values I have. So now writing them here, I will get 152 divided by 12, and ultimately we will get here 38 divided by 3, which is the answer of question 4.6. Okay, and that is the expected value it has. Okay, so this was what? This was question 4.6. Okay, now let us proceed to question 4.7. Okay, and the solution of it, we are going to write it here, and let us go through its statement. So by investing in a particular stock, a person can make a profit in 1 year $4,000 with probability 0.3, or take a loss of $1,000 with the probability of 0.7. Okay, so 1,000 loss, a loss of 1000 has a probability of 0.7, and a profit of 4000 has a probability of 0.3. So let me first write this data, and here profit is also written as a positive value because this is always positive, so it is positive, and it has a probability of 0.3. Okay, also we have a loss of 1000, and as this is a loss, so I have to write it with the negative value, and it has a probability of 0.7. Okay, so this is a given data I have written. What is this person's expected gain? Again, to find the expected gain is basically the expected value. How can we find it out? This would be what? This would be again E of x, and by using the same formula where these are basically the values and these are the probabilities, let me multiply the values with the probabilities. Okay, and at the end adding them together. Okay, so let me calculate it. So 4000 multiplied by 0.3, it would be $1200. Okay, and also this 1000 multiplied by 0.7, and this is as negative, so it would be minus 700. Okay, so subtracting 700 from 1200, we will get 500, so it would be 500 USD, and this is a profit of 500 USD, which is the answer of question 4.7. Okay, and that is the solution of question 4.7 as well. Okay, so you have seen that it is very easy to calculate the probability or expected gain out of any business if you have the probabilities of the profits and loss as well, and this is by using this formula. Next question is also relevant, so let us go through its statement first. So the statement of it is: suppose that an antique jewelry dealer is interested in purchasing a gold necklace for which the probabilities are 0.22, 0.36, 0.28 and 0.14. Okay, so let me first write these probabilities. So 0.22, 0.36, okay, 0.28 and 0.14. Okay, so these are basically the probabilities given that she will be able to sell it for a profit of $250, sell it for a profit of $150, break even, or sell it for a loss of $150. What is her expected profit? Okay, so as their values are also given, let me write this: 0.22 is for $250 profit, so it will be positive. Okay, this is 250. This 0.36 is for $150 profit, so it will be 150, positive 150. This 0.28 is for break even, and break even means that he is neither getting a profit nor a loss, so therefore here I have to multiply it with 0. Okay, and at the end this is 0.14 for a loss of 150. Okay, and in previous question we have seen that for a loss you have to write the negative value with the value of a random variable, so it would be minus 150. Okay, and at the end what do I have to do? I have to add these values together for the expected value. Okay, so I have to add them all together, and in adding them all together, what will you get? You will get 88 USD, which is basically the solution of this question which we had here. Okay, so the only part here was basically writing the negative values with the losses, positive values with the profits, and also zero value with the break even values. And this is what this is, again, the expected value of X or expected profit. Okay, so that's it for today, in which we have discussed some relevant questions of chapter 4. If you have any question, you can ask me in the comment box. See you soon.